Yes, friends. Yeah, in morning class, we completed till question number 15. So I'm going to do question number 16. See here, whenever here the limits are same and opposite sign, we have to check whether the given function is even function or odd function. But the thing is, here log will be there. Log will be there. We cannot find. So that 16. 16th question, I is equal to integral minus 45 to plus 45. Okay, and log sin x, sorry, cos x plus sin x into dx. This is the question, equation 1. So I'm going to apply the property. This is in the form of a b, like a to b f of x dx. What is the third property? This can be written as f of a plus b minus x dx property. This property can apply students here. If I apply this property here, I is equal to, like see, a plus b minus 45 plus 45, 0. 0 minus x is minus x. Okay, plus 45 log of cos of minus x plus sine of minus x. A plus b minus x value is only minus x into dx. So this is clearly cos of minus theta is plus cos theta minus 45 to plus 45. So this is clearly cos x minus sin x will get dx. Let us take this is 2. Adding 1 and 2. When we are adding 1 and 2, I plus I left side is 2i is equal to integral minus 45 to plus 45 is common. In first one, log of cos x plus sin x plus log of cos x minus sin x. So log a plus log b formula. Shall I write directly here? Cos x plus sin x here into cos x minus sin x. When I adding equation 1 and 2, log a plus log b formula will get log a plus log b. Log a plus log b is log ab. A value is here, the value of a is cos x plus sin x. Value of b is cos x minus sin x. So log a plus log b is log ab I have written here. So this is clearly what, students? Left side is 2i is equal to integral, okay. Log of here clearly cos square x minus sin square x. Minus 45 to plus 45, right, into dx. So this is nothing but integral minus 45 to plus 45. Yes, here this is clearly log of cos square theta minus sin square theta is cos 2 theta. So cos 2x. Finally, we got this cos 2x. 2i is equal to. Now let us take this is 2. Now see here, clearly cos 2x is an even function. Cos 2x is even function. Whenever it is even, minus a to a can be written as 2 times of 0 to a. 0 to 45 log of cos 2x into dx. We can write. Let us take this as equation 2, right? 0 to like minus a to a can be written as 2 times of 0 to a, then log of this, because cos 2x is even, log of cos 2x also even. Whenever even, we'll write. Whenever it is odd, we'll write directly 0. Okay, but we know that here, we know that what is the value here? Log of cos x value is minus pi by 2 log 2 here, but 0 to pi by 2 here, 0 to 90, pi by 2 means 90, but here 45 is there. What shall we do? Shall I take here 2x is equal to t? Take 2x value as t, 2x is equal to t, then x is equal to t by 2 and dx is equal to dt by 2. This already we done. When x is equal to 0, here t is becomes 2 into 0, 0, x is equal to 45 and t is equal to 90. Got it? Substitute all these values in this equation. So I is equal to 0 to pi by 2, 90 nothing but 5 by 2 log of this is cos t into dt will get dt by 2. So what about this value, students? This value already minus pi by 2. Look at here. What is the formula? Yeah, what about the value integral 0 to pi by 2 cos x dx? Same, minus pi by 2. So 1 by 2 you can take it outside. So 1 by 2 times of minus pi by 2 log 2. The answer is minus pi by 4 log 2 is the answer. Minus pi by 4. Is there any answer? Yes, third option. What I have done? What I have done? Here I have applied the property, one of the property A to B, and second I applied like I'm adding and everything. I applied that uh, minus A to A. If I checked that whether it is even or not even, so I have written 2 times of 0 to A. Then at last, what I have done? So after taking this 0 to A, I'm taking 2x is equal to t. 2x is equal to t, we got the answer directly. Easy question. Next, question number 17. 17 you can try, student, with help of 0 to A. It is just 2 or 3 steps will get the answer. 2 or 3 steps the answer. Okay, when I apply the property here, let us take this is equation 1. This I is equal to equation 1. Apply the third property or fourth property, like 0 to pi by 2. Sin square 90a minus x. 90 minus x becomes cos square x by denominator sin x plus cos x will be same. When we are adding these two equation, numerator sin square plus cos square becomes 1. So finally 2I is equal to integral 0 to pi by 2 1 by sin x plus cos x. Yeah, this value already is there. What about this value, Amma? 0 to pi by 2? Yeah, 0.8. Yeah, 0 to pi by 2, 1 by sin x plus cos x is root 2 times of log root 2 plus 1. So can I substitute here directly? Yeah, can I substitute here? Yes. So 2I is equal to 2. Yeah, the value is log root 2 plus 1. Okay, 2I is equal to, sorry, root 2 times of root 2 times. So when I cross multiply is equal to 1 by root 2 log of root 2 plus 1. Which of the option is correct? Second option. So I applied the property, third property, and after that I substituted the value directly, we got the answer. That's it. 2 steps. Yes, twin, this kind of question already we have done. Take sine inverse x is equal to, you can take as t. You can do this. That is easy only. Sine inverse x is equal to t, then substitute upper limit and lower limit. T limits we are going to get 0 to t is equal to pi by 2. Lower limit will get 0, upper limit will get pi by 2. That's all. You can do it. Easy, very easy. Right here, what to do here? X is equal to tan theta, because 1 plus x square is there. Okay. This is also you can try, students. Easy questions and all I'm giving you. Even in case if you get any doubts, I'll explain in next class. Okay. Tan x is equal to. This kind of questions are quite logical question. Here nothing, 1 plus x square means take x is equal to tan theta. But this kind of question, what to do here? 2x minus 1 by. So it's a logical question, like take I is equal to 20 is equal to 0 to 1 tan inverse of 2x minus 1 by 1 plus x minus x square into dx. Got it. Right. See, there is a formula. There is a formula. Can anyone tell that what is the formula for tan inverse x plus tan inverse y? Is equal to tan inverse of x plus y by 1 minus xy. Got it? So I is equal to integral 0 to 1. This tan inverse I want to written as x plus y by 1 minus xy. I want to write like that. So shall I write x plus x minus 1 by, like here 1 plus x into x minus 1. You can take minus, sorry. Yeah, minus x into x minus 1. Shall I? 1 plus x minus x square is there. 1 plus, when you take x common, 1 minus x. But when I take minus x, x minus 1. X minus 1 we required. Because I want to consider here it is a, this is a, this is x, this is y. 1 minus x into y. Got it? Numerator is x minus 1, denominator also must be x minus 1 into dx. So it is in the form of RHS tan inverse x plus y by x minus 1. Shall I write here this is equal to 0 to 1 bracket tan inverse x minus tan inverse of x minus 1. Yes, we can write into dx. Got it? Simply I applied tan inverse x plus y by 1 minus xy formula. So since we know that, okay, now onwards, okay, it's not a problem. So integral of 0 to 1 tan inverse x dx minus integral 0 to 1 tan inverse of x minus 1 into dx. Got it? So what about the tan inverse x? The tan inverse x and all you can do UV rule, or else you can substitution method. Here you can take your tan inverse x is equal to t. Your tan inverse x minus 1 is equal to some v. Okay, you can find the limits x is equal to tan t, dx is equal to secant square t. Already we done this tan inverse x. Here also x minus 1 is equal to tan v, x is equal to 1 plus tan v, then dx is equal to
26 plus.
oh, it is plus. Yes, Murugan?
Yes, that only has plus or minus.
Plus only, I forgot. If numerator is plus, here plus. Numerator is minus, then we'll take minus. Can you do this step onwards? Because you have to practice well. Yourself, you have to practice. Got it? Here tan inverse x. First, once you can derive the tan inverse x formula, what is sine inverse x, what is tan inverse x, what is cos inverse x. Okay, these problems are done, you have to practice it. Got it? So simple, if you want to do, you can do like, say tan inverse x, why don't you do direct tan inverse x into 1? This is u, this is v. Because inverse function always first. UV rule. So tan inverse x integral 1 into dx minus integral tan inverse x derivative into integral 1 dx. So 1 means x tan inverse x minus tan inverse x 1 by 1 plus x square, here x into dx. See here x tan inverse x formula I'm deriving here. So x by 1 plus x square, I want to do multiply and dividing with 2 dx. Look at here, this is in the form of f dash of x by f of x. So x tan inverse x minus 1 by 2 times of log of 1 plus x square. This is the formula for tan inverse x. So like that we'll get. Now after getting this, you can substitute the limits. That's all. This is the formula x tan inverse x minus 1 by 2 log 1 plus x square is the formula for tan inverse x. In the same way, you have to derive sine inverse x and cos inverse x. Try to remember the formulas. Try to remember the formula. Because always we cannot derive, instead of derive, if you remember this formula like x tan inverse x, for example, sine inverse x is there, x sine inverse, cos inverse is there, x cos inverse, that is must. That is must. Okay. Anyhow, you can do that. Then I'm going to do this 21st. So here minus pi to pi. UV rule I applied.
Thank you, sir.
Yeah. The next question. 22nd. The question is 21st. Question is easy. The value of integral minus pi to pi cos square x by 1 plus a power x dx. Here a is, what is a greater than 0? Yes, can anyone say that is it even function or odd function? The given integrand cos square even, then what about the 1 plus a power x? Yes. So fine. Here, what I want to do, I want to apply the property. Same, I told you one of the important property a to b f of x into dx is equal to f of a plus b minus x dx. Got it? A to b. When I apply this property, if I take this is given question as I is equal to this. Here minus pi to pi uh, cos square. Yeah, what is when I adding these two limits, minus pi plus pi, 0. 0 minus x is minus x by 1 plus a power minus x into dx. Got it? Yeah, this is equal to minus pi to pi. Cos square, okay, cos square x alone will get, but whereas this is 1 plus 1 by a power x dx will get. When I take LCM here and simplify, we are going to get minus pi to pi a power x into cos square x by a power x plus 1. Okay. Okay, got it. Okay, a power x plus 1 we are getting, this is dx. So let us take this is 2. This is 1, given question is 1, equation 2. I'm going to adding both the equation I plus I. Left side is I plus I, minus pi to pi is common. But from the first one, cos square x, from the first one is cos square x, from the second equation a power x into cos square x by 1 plus a power x is common, denominator also common. But when you apply the cos square, when you take the cos square x is common, minus pi to pi, what about the remaining one? Cos square x take common, 1 plus a power x get cancelled. So finally, cos square x alone will get. And cos square is even or odd? Even or odd? Even. So shall I write 2 times of 0 to pi cos square x dx? We'll write it. Yes, we can write. 2 to get cancelled. Let us take this is 3. Now in 3, again there is a property. Like integral 0 to 2a f of x dx can be written as 2 times of integral 0 to a into f of x dx, where here f of 2a minus x is equal to f of x. We can write simply. You can observe your students, if it is even function, we can write like this. What about cos square even? Cos square even. So shall I write here pi as 2 into pi by 2? 2 into pi by 2, 2a, comparing with 2a. So shall I write here I is equal to right side is again 2 times of 0 to pi by 2.
Excuse me, sir.
Yeah.
Sir, could you please scroll down, sir? 1 second, sir. Yes, sir. 1 second, sir.
Yeah, no problem. Integration in calculus, integration is one of the fantastic concept. If you practicing more number of problem, you know you'll get a lot of interest, as well as like for all the question you will get the solution.
Sir, could you explain the property alone once more, sir?
What property? This property or all the properties?
Sir, no, sir. Second one, you have marked second one, no, sir. That one.
Here, this one.
Yes, sir. Yes, sir.
This property. Do you understood this property?
Yes, sir.
What is A? What is B? Yeah, A value is minus pi. So first you have to find A plus B minus x. So minus pi plus pi. Okay, minus x. So that is nothing but minus x. Get cancelled. So with help of this, I replace minus x. So here, after this, replace x by minus x. That's all. So I replaced in place of x minus x in equation 1. Okay. In integrand alone, you have to replace, not in place of dx, right? Okay, cos square x, cos square of minus x, cos square x. Here a power minus x becomes 1 by a power x. When I take LCM, you know, what is LCM here? A power x is LCM. Here a power x plus 1. This a power x becomes numerator, am I right? This is cos square x by this. This becomes a numerator. So that I have written directly here. Got it?
Yes, sir. Thank you, sir.
I have written directly. So after that, adding both equations. When we are adding, first one is cos square, second one a power x cos square, take cos square is common. When I take cos square is common, 1 plus a power x, it cancels. So finally, cos square alone will get. But in NCERT, we have solved one question. The first question in 7.11. What is the first question? 0 to pi by 2 cos square x. What is the answer I have written? Pi by 4. Here also I am going to change 0 to pi by 2, but here we got 0 to pi alone. But cos square is an even function. This pi I have written, 2 into pi by 2. 2 to get cancelled, again will get pi. So with help of this, with help of this property, I have written like this. Then now what about this value, Amma? This NCERT problem, pi by 4. The answer is pi by 2. That's all. So the answer for this cos square by 1 plus a power x dx is, the value is pi by 2. Any answer? Yes. Third option. Got it? It's not involving on a. 1 plus a power x get cancelled. Okay, students. This question and all you have to do it. This question and all you have to do it. It is very simple question. First is here 2 to 5. Shall I write this as greatest integer of x minus 7 the whole square?
Excuse me, sir.
Yes.
Can you first slide, sir? Right, sir.
Sorry, you want to slide?
Sir, okay, sir. Okay, sir.
Yeah. This x square 49 can be written as 7 square 2ab. So a square plus b square plus 2ab form. This is a minus b the whole square. Fine. Here same x minus 7 the whole square. Greatest integer plus x square. Now dx. This is equation 1. Let us take this is I is equal to 1. Now apply the property 0 to a. When I apply the property, see here, what is that? A plus b, 2 plus 5, 7, 7 minus x. You have to replace, then equation 2 you are going to get the same 2 to 5. But here x minus 7 whole square becomes x square. Here x square plus here x minus 7 the whole square. Okay, dx will get like this. When I replace x by 7 minus x, yes, replace 7 minus x. So 7 get minus x whole square means x square alone. I have written directly. When I adding these two equations, this is 2. 2i is equal to 2 to 5. Numerator denominator is same when we are adding that. Here 1 dx like NCERT. X from where to where? 2 to
Sir, you explain the 7-step alone again, sir.
where, this one?
Yes, sir.
Yeah. See, I'll explain here. Here 2 to 5. Fine. Greatest integer x minus 7 the whole square by here x minus 7 the whole square plus x square dx. Okay, let us take one. This is I is equal to. I want to apply the property a to b f of x dx is equal to f of a plus b minus x property. So what is a plus b minus x value? What is a plus b? Nothing but replace x by a plus b minus x. Nothing but 2 plus 5 minus x. So replace x by 7 minus x. But 7 minus x by vice versa. Nothing but replace x by 7 minus x means 7 minus, see here x minus 7 have written whole square. You may write, okay, for the sake of our convenience, you may write like this. 7 minus x you can write. Whole square only, no? 7 minus x, 7 minus x. Whole square. Either x minus 7 you can write or 7 minus x. Shall I, when I replace x by 7 minus x, then 7 minus x you can replace by x. That's all. When you replace, you are going to get this equation. So x square by 7 minus x the whole square plus x square. When we are adding these two equations, numerator denominator becomes same, get cancelled. Got it? Get cancelled. We are
Understood, sir.
getting 1. This kind of question you can more concentrate. Okay. This you can do. Now I'm going to explain 23rd. Okay, I think I don't know why it's. Okay, fine. Next question. It's a logical question. They asking k value. They asked here k value. For finding k value, they have given one condition. See, students, I am going to take this value. Okay. Both the condition. First, tell me what is the first one condition. D by dx of 23rd. D by dx of capital F of x is equal to e to the power of sin x by x. X is greater than u, right? Then when we evaluate 1 to 4, here it is 3 by x e to the power of x cube dx, sorry, sin x cube. Sin x cube dx is equal to f of k minus f of 1. Then the value of k. Fine. Is it difficult? No. See, when I when I integrate on both sides here, integral, derivative integral get cancelled. Remember, students. So capital F of x, we are going to get integral of e power sin x by x into dx. When I take integration on both sides, integral derivative get cancelled. Fine. Now this LHS I want to take LHS here. What is LHS? 1 to 4, 3 by x, e to the power of sin x cube into dx. Now let us take this is 1. In 1, I want to take x cube is equal to t. When I take x cube is equal to t, 3x square dx is equal to dt. Dx is equal to dt by 3x square. Fine. Now I am going to substitute all these values in 1 LHS. The LHS becomes, okay, I is equal to, like what are the limits, Amma? Limits. When x is equal to 1, t also 1. When x is equal to 4, t is equal to x cube, 4 cube, that is 64. Limits are 1 to 64 and 3 by x is there into e to the power of sin t, and dx value is dt by 3x square. 3 get cancelled. 3 get cancelled. So I is equal to, we are going to get 1 to 64 and e power sin t by, what is x into x square, Amma? X into x square is x cube. X cube value is t. Shall I write here? It is t. Shall I write? What
sir.
is, yeah, what is integral e power sin t by, when I take in place of xt, we may take variable, you can change, no problem. So what about that value? That value is capital F of x. Fine. Shall I write this is equal to capital F of x from where to where limits, sir? 1 to 64. Now apply the upper limit f of 64 minus f of 1. But this you can comparing with this is equal to what? F of k minus f of 1. What is k value? K value is 64. Once again, see they have given one condition. I'm taking integration on both sides. We got capital F of x. Okay, fine. So I'm taking the given integral 1 to 4. LHS alone, I'm taking x cube is equal to t, and I differentiated. I changed the limits and I substituted all the values. Finally, we got 1 to 64 e power sine t. This value is capital F of x, nothing but F of t. Substitute upper limit minus lower limit and compare with RHS. When I comparing with RHS, k value is 64. That's all. Mostly either will get 64 or cube of some value. Okay, anyhow, the 64 we got it here. Next, coming to this question, this is we'll do in two ways. One of the ways x cube is equal to t square. X cube is equal to t square, but they asking in the question, they do not given any particular value in this question, students, and simply they ask lesser than and greater than or between. This kind of question, 1 plus x cube is 1 plus x cube is, yeah, what are the limits they have given amount? 2 to 3 means in the interval 2 to 3. What about 1 plus x square? I'm going to take some standard form. Is clearly greater than to 1 plus x the whole square. Got it? Take any value from 2.12 till 2.9. Take any value here. See 2 to 3, 2 to 3 nothing but you should take as open interval. Open interval. So here from 2 to 3, 1 plus x cube is greater than. Take 2.1, 2.2, substitute, and if you get any doubts, you can verify that it is greater than only. But here square root is there. Square root of 1 plus x cube is greater than to square root of 1 plus x the whole square. Square root cancel. But it is in reciprocal. 1 by 1 plus x cube. Greater than becomes lesser than 1 by 1 plus x. Now, but here integral is given. So take on both side integral 2 to 3. Here also integral 2 to 3. Just evaluate this value. That's all. So 1 by means this is clearly log 1 plus x. Okay, 1 by 1 plus x integral is log from where to where? 2 to 3. Substitute here. Upper limit log 1 plus 3 is 4 minus log 2 plus 1 is 3. So log of 4 by 3 will get. Log of 4 by 3 value is what? Is it greater than 1? No, log of 4 by 3 is lesser than 1. First one is 1. 4 by 3, nothing but 1 point something. Log of 1 point something will be clearly lesser than 1. Because you know why it is lesser than. How can we say that? 4.4 by 3 means 1 point something. But log e value is 1 we have written. Log e is 1. What is e value, Amma? E value is? Yes. Okay. Is here 4 by 3 is lesser?
303.
Yeah. Is here 4 by 3 lesser than e or not?
Yes, sir.
Take log on both sides. Log 4 by 3 is lesser than log e. Nothing but log e value is 1. Shall I write log 4 by 3 is lesser than 1? Yes. We can. So finally, the answer is first option. The answer is the first option. Got it? Less than 1. Fine. Simple question. Now problem based on UV rule. Problem based on x into f of x. X into f of x means, in this case also we are going to apply like integral a to b f of x dx. Got it? Okay, 25th one. I'm going to open as new. Okay. Just a moment, students. Yeah. So got it. So here we got k value. Then after this 25th one, what is the question? I is equal to integral from where to where? Minus pi to plus pi, like 2x 1 plus sin x 1 plus sin x by 1 plus cos square x dx. Okay, students, this you can take as equation 1. Got it? So I'm going to do one thing. Like I want to multiply with the 2x. Shall I write here integral 2x by 1 plus cos square x dx? When I multiply 2x to sin x is here 2x sin x by 1 plus cos square x. Yeah, minus pi to pi. There is an advantage is there, this kind of questions. What are the limits? Limits are same. The limits are same, but opposite sign. Limits are same, opposite sign. Got it? When the limits are same, opposite sign, if it is odd function, if it is an odd function, then odd function means then 1 plus cos square x is, see, odd function becomes 0. I told you very clearly. Even function we can write 2 times of 0 to a. What about 1 plus cos square x? Denominator is even, but numerator is x is odd. Odd by even, odd only. So that this is 0. Second one, x is odd. Okay, denominator cos square x is clearly even. X is odd, sin is odd. Odd into odd becomes even. This is finally even function. So whenever it is even, minus pi to plus pi can be written as 2 times of integral 0 to pi into 2x sin x by 1 plus cos square x into dx. So see students, finally I becomes 4 into integral x sin x by 1 plus cos square x dx from 0 to pi. Now I am going to apply the property, third property in whatever I said in NCERT. 0 to a f of x dx can be written as what? Integral 0 to a f of a minus x dx, right? So this you can apply here. So I is equal to integral 4 from 0 to pi, uh, pi minus x, a minus x sine pi minus x by 1 plus cos square pi minus x into dx. Got it? I apply this property. So when I apply this property, 4 times of integral 0 to pi. See, what about this twins? I want to multiply with what is sine 180 minus x? Sine 180 minus x. Sine x by 1 plus. What about cos square 180 minus theta? Minus cos theta. But square is there. Square is there. So that whenever it is square, same value will get. So after this, I multiplied and x into sine. Shall I write separately? I am writing separately 4 into integral x sin x by 1 plus cos square x into dx. From equation 1, what should we write this value, Amma? Anyone? What about this value becomes? From equation 2, 4 into integral 0 to pi, same value only, no? Shall I write I? This is? But here, see, when I take I here, when I take I left side, it will become 0. Is that right? But we have done one mistake. What is that mistake? Is it plus or minus? Yes or no? What about here? Minus is there. But I have taken plus. That is only mistake. This minus I you can take left side 2i is equal to 4 times of pi you can take outside 0 to pi. Now sin x by 1 plus cos square x into dx. Now onwards we know the procedure. Now cos x is equal to t. This cos x is equal to t, sin x dx is equal to minus dt. Then this is becomes a dt, just you can change the limits, you can simplify. Got it, students? Till now I think so you understood. Whenever x into some function, always we get like this. I multiplied with 2x, first and second. First one is odd function 0, second one is even. So whenever even, 2 times of 0 to a, if it is having same limits, like that I have done. I simplify finally. Now onwards, already we know this the same question is there in NCERT. And also we solved this question in NCERT without limits. Indefinite integration we solved. You can do that. Now coming to the question number 26. Here,
So one slide, sir.
Yeah. Oh. Why it is video is stopped? I don't know. Sorry.
Yes, sir. Thank you, sir.
Yeah. The next question is 26. I is equal to integral 0 to, minus 1 to 3. Tan inverse of x by x square plus 1 plus tan inverse of x square plus 1 by x into dx. Okay, fine. This is in the form of tan inverse x plus tan. Yes, students, am I audible?
Yes, sir.
Yeah, actually, power gone, Wi-Fi network is disconnected. Okay, fine. Now we are doing this question. When you see this question, your tan inverse x plus tan inverse y is tan inverse of x plus y by 1 minus xy. This inverse trigonometric property. So I is equal to minus 1 to 3. Yeah, apply this property, then tan inverse of x by x square plus 1 and plus 1 plus x square by x by 1 plus 1 minus 1 minus x by x square plus 1 into x square plus 1 by x get cancelled. What is the denominator amount? Tan inverse of anyone? Minus 1 to 3. Tan inverse of 1 by 0. 1 by 0 will something by 0 will get. Something by 0 means yes, anything by 0 is infinity into dx. What is tan inverse infinity? Students, anyone?
Pi by
Yeah,
2.
pi by 2. Pi by 2 you can take outside. Here 1 will be there. 1 is integral is x from minus 1 to 3. That is nothing but pi by 2. 3 minus of minus plus 1. 3 minus of minus 1, it is plus 1. So that is nothing but 2 pi. Answer will be 2 pi will get. Got it?
Yes, sir.
Yeah, this is the answer. Two pi.
Sir, 1 minute please show the screen, sir.
Yeah. First of all, it is in the form of tan inverse x plus tan inverse y. There is a property this. Apply this property. Denominator becomes 0. Something by 0 is infinity. Infinity value is pi by 2. Pi by 2 I am taking outside. Pi by 2 take outside. Then integral 1 is x. Okay. Got it. Now step functions. Step functions are interesting questions as well as important. Mains 2009. Okay. This question is belongs to mains 2009. And also remember students, cot x minus cot x is always is equal to minus 1. Tan x minus tan x always equal to minus 1. There is a property. Before, why I am telling this property? Because okay, 527th question. Let us equation. I want to apply 0 to a property. 0 to pi. Cot of what is 0 to a property? Pi minus x dx. Fine. So I is equal to integral 0 to pi. What is cot 180 minus theta? Second quadrant cot becomes negative. Cot becomes minus cot x dx. So let us take this as 2. Now adding both the equations 1 and 2, left side is I plus I, right side is integral 0 to pi. 1 is from equation 1 cot x, from equation 2 minus cot x into dx, right? Since just now I have written one property, cot x minus cot x is minus 1. So 2i is equal to 0 to pi. This is minus 1 into dx. Minus is outside, you can take here x from where to where? 0 to pi. Now apply the upper limit and lower limit. So 2i is equal to minus pi minus 0. That is nothing but minus pi. So I is equal to minus pi by 2 is the answer. Just apply the third property. That property, important property. So minus cot, both will be minus 1. Minus 1 I'm taking outside. It is x from 0 to pi. So minus pi by 2. Any option here? Yes, third option. Got it? Is it difficult? And coming to this kind of algebraic functions, I'm going to tell you shortcut methods whenever it is square, whenever it is cube, whenever it is root. cube root, square root, cube root, like that. Whenever it x is there, you have to divide the given integral to like 0 to 1, 1 to 2, or 2 to 3, so on, like that. Whenever it is x square, we can divide that 1 to 0 to, if we start with 0 to root 1 plus root 1 to root 2 plus root 2 to root 3 until they given upper limit. According to the upper limit, you have to go. If they given greatest, like this in this case, in case if they given greatest x cube, this you can like 0 to cube root of 1 plus cube root of 1 to cube root of 2 plus cube root of 2 to cube root of 3, cube root of 3 to cube root of 4, so on. Got it? So on. If it is x power 4, okay, this is fine. What about root x? Whenever it is root x, 0 to 1, 1 to 2 square, 2 to 2 square to 3 square, like square, like just you have to equating some other variable. Then what is x? T square. Root x is equal to t, x is equal to t square, like that. Square. If it is a cube root of x, you have to divide the interval 0 to 1 cube plus 1 cube to 2 cube plus 2 cube to 3 cube, like that. So this kind of values we have to remember. X means every integer, like 0 to 1, 0, 1 to 2, 1, 2 to 3, 2, like that. In the same way, square will be there. Like x square is there. X square is equal to, you can take some other variable, like x square is equal to t. When x square is equal, x is equal to root t. Nothing but root 1, root 2, root 3, root 4, root 5. X cube is equal to t. X is equal to cube root of t. So like that. Okay. Here x square is there. X square. So integral 0 to 1.5, 0 to 1.5 x square, greatest integer of x square into dx. This is I. This is question number 28. See, what shall we do here? Let us take this is 1. Now we can split into different integrals, like I is equal to, right. What about the first one? I said x square is there. X square is equal to t, nothing but x is equal to root t. Don't substitute, but simply you can resolve 0 to root 1. Okay, 0 to root 1, x square into dx plus root 1 to root 2. Root 2 is more than 1.5 or lesser than 1.5 students?
Less than 1.5.
Lesser than, so root 2. X square step x square dx, then root 2 to root 3. What about root 3? Root 3 is clearly greater than 1.5. Am I right?
Okay.
So that till 1.5. That's all. Don't take like 3 here, because root 3 is greater than 1.5. So that till 1.5. So once again, here square is there, x square is there, so that 0 to root 1, root 1 to root 2, root 2, 1.5. If it is 2.5, we may take root 3 also. Root 3 to root 4, root 4 to 2.5. Until you have to write all the values. Okay. Now, fine. Now, when I substitute the value in place of this x 0 to 1, what about the greatest integer of x square? 0 to 1. X square value?
Root t.
Yes, real line. Here 0 will be there, here 1 will be there, here 2 will be there, here 1.5 will be there. 2 means, right, okay, 2 will be there, 1.5 square means 3.5 something. Not 1.5, is 2 point something will be, 2 point something. Okay, fine. Here integral 0 to 1. When I put root 1 here, root 1 square is 1. 0 to 1. What is the greatest integer value?
1.
0.
Sir, but it is coming on 1, sir.
Huh?
Sir, but it is coming on 1 itself, no, sir.
Why 1 itself? When I substitute 1 here, square root of 1. See, here it is, we cannot include square root. It is open interval. Yeah, your answer is correct only. When we substitute root 1 here, root 1 means 1 will get, but we cannot include this open interval. Other than root 1 means till 0.999, like that. Got it?
Yes, sir.
Okay, so what is the value? 0 plus. Okay, 1 to, when I substitute root to 2, 1 to 2 between. Always remember, student, this is we can consider as open interval, lower limit, comma, upper limit. So till 1 to 2, what about the x square value? Shall I take 1? Yes or no? Least value only will get 1.12, 1 to till 1.999, the greatest integer of is 1. If you are not understood here, please try to ask here, okay? When we substitute like open interval 1, 2 to 1.2 point something, what about this value?
1.
2. Minimum value is 2. When we substitute root 2 whole square is 2. More
Okay,
than
sir.
that. Got it? Dx. All of you
Yes.
understood? Yes.
Nothing, sir.
Having any doubts, you can ask students. Okay, logical questions, and I told you greatest integer function questions very important and very easy actually, but logically how to do. So now I substituted. Now okay, your first one is entire completely 0. Second one is x square integral is x cube by 3 from where to where? 1 to root 2. Same next one is 2. 2 is outside. Same x cube by 3 from where to where? Same root 2 to 1.5. Okay, substitute these values, upper limit minus lower limit, you will get the answer. You may get any one of the answer. Correct answer, you will get it. Got it? Okay, students. Substituting the limits is not an issue. So first, how to evaluate the definite integration is alone important. Okay, integral 0 to 1 or 2. This is also logical question. I is equal to integral 0 to 1 to 0 to 1 or 2. Tan inverse x into dx. Okay, here also greatest integer function we can split. Okay, here something greatest integer not exceeding x, not exceeding x. Yes, see students, so there is a one condition actually here. So what is the condition here we are having? The condition is that see, when I take x value like 0 lesser than or equal to x lesser than or equal to tan 1. Okay, when I take inverse, tan inverse 0 lesser than tan inverse 1 is lesser than tan inverse of tan 1. Tan inverse tan get cancelled. Here tan inverse 0 is 0, tan inverse x nothing but given integrand and it is lesser than 1. So this is 1. After 1, again tan 1 I am taking, tan 1 lesser than or equal x lesser than or equal, direct 1 or 2. Directly till 1 or 2. This only 2 intervals are there. Because highest value of tan is infinite. Tan infinite is pi by 2. What is pi by 2 value? Pi by 2 is 22 by 14, nothing but 1 point something. So maximum value here it is 1, whatever the value. What is, if you take here x is infinity, what is tan inverse infinity? Pi by 2. Pi by 2 nothing but 1 point something, nothing but maximum value it will be reached to plus 1 alone. For any value of x, till just they have given till 1 or 2. Only 2 cases, that is 0 to tan 1, here tan inverse x dx plus tan 1 to 1 or 2 tan inverse x dx. Got it? So after this, yes, 0, minimum value is 0, nothing but here 0 to tan 1, this value always 0. When I substitute the limits, tan inverse of tan 1, nothing but 1. So here integral tan 1 to 1 or 2, this value becomes 1 into dx. Got it? Maximum value is 1, that I told you. So this is 0 plus here x from where to where, tan 1 to 1 or 2, nothing but 1 or 2 minus tan 1 is the answer. Once again, the maximum value becomes 1, but here clearly we know that 0 is lesser than or equal to x is lesser than tan 1. So when I take tan inverse on both sides, we got the limits 0 to 1, remaining one tan 1 to till infinity, but instead of infinity they have given just 1 or 2. Okay, so tan 1. Any doubts, students here? Having any doubts? Just 10 minutes, I'll take the class 10 minutes, then we'll wind up the class. Okay.
Yes.
Yeah, Gokul, is it clear?
Yes, sir. Clear, sir.
Yeah, question number 30th. See, like if you're having sufficient time like this, we can discuss briefly. Like I may clarify your doubts also. Even you may also ask the doubts because less number of students here. Okay, shall I write here minus 2x greatest integer plus 1? The given integrand I have written like this. So this is, let us take one. What about this value? They are asking. So this is in the form of a square plus b square minus 2ab. And shall I write 1, 2, 3 like dx by x minus greatest integer of x, the whole square, a minus b whole square plus 1. Clear? Right, here greatest integer. Greatest integer nothing but what I told you. Interval you can divide like this, 1 to 2 plus 2 to 3 like that. Got it? Right, when I take here I is equal to integral 1 to 2 plus 2 to 3, that's all. It's not x square, it's not x cube, it's not square root of x, just greatest integer of x. So in that case, dx by, right here, yeah, bracket x minus, what is greatest integer of x? I want to substitute directly this greatest integer here. Okay, what is the greatest integer from 1 to 2? Anyone?
5.
1, absolutely right. 1 to 2, just lower limit alone will get. Just take the lower limit, whole square plus 1. Okay, next dx by, yeah, x minus, what is the greatest integer of x from 2 to 3? What is lower limit? 2, whole square plus 1. That's all. Just you can evaluate this. This is directly in standard form, like integral dx by x square plus 1 square, x square plus 1 square, x square plus a square. What is the formula? Tan inverse of x minus 1. From where to where? Tan inverse x formula 1 to 2. Here also same. Tan inverse of x minus 2. From where to where limits are 2 to 3. Now upper limit. For upper limit it is clearly tan inverse of 2 minus 1 is 1 minus tan inverse of 0 plus tan inverse of 3 minus 2 is 1 minus tan inverse of 0. Got it? So finally 2 tan inverse of 1. Tan inverse of 1 is pi by 4 minus 0. That is nothing but pi by 2 is the answer. Yeah, got it? Having any doubts here? What I have done here? I have written a minus b the whole square. Then after I split into two integral because step x is there. So 1 to 2, 2 to 3, then 1 to 2, 1, 2 to 3, 2, then it is directly standard form tan inverse x like that. Got it? Pi by 2 is the answer. Having any doubts, you can ask. So like that, see student, here root x is there, greatest integer inside root x. Yeah, here also we have to split, but split into 0 to 9. This kind of questions are 0 to 9 is there, but greatest integer of root x plus 2 is there, dx. This is I. Yeah, very easy question. Yeah, root x is equal to some variable. That means x is equal to t square. Squares we can write. Okay, I is equal to, we can split into 0 to where? 1 square plus 1 square to 2 square plus 2 square to, what is the upper limit until you get upper limit, you can do like that, squares alone. What is the upper limit? 9. 9 nothing but 3 square. You can stop it. If it is some 25 is given, you can write 3 square to 4 square, 4 square to 5 square. That's all. Got it? In case if they give 8, instead of 9, 8. Instead of writing 3 square, you can write 8. Like that. Got it?
Yes, sir.
Is it clear? Now, see, I'm going to write directly here. What is the root x value from just here also just write a lower limit value 0 plus 2 to dx. A 1 square means not 1 square, 1. Don't consider square, 1 plus 2 dx. Because when you substitute 1 square here, square root of 1 is 1 only. If you substitute the square root in place of square root x 2 square, 2 only. That is nothing but lower limit is 2, 1. So 2 plus 2 into dx. Got it? Yes. So here 2 is a constant. X from where to where? 0 to 1. Here 1 plus 2 is 3. 3 is a constant outside x. From where to where? 1 to 4. Here 4 is a constant, take outside. 4 times of x into, from where to where? 4 to 9. That's all. So 2 times of 1 minus 0. 3 times of 4 minus 1. 4 times of 9 minus 4. Nothing but 2 plus 9 plus 20. Yeah? This is nothing but 29 plus 1, 31. 31 is the answer. First option. Students, did you get my point here? Is it clear or any doubt?
Sir,
So
when do we substitute that lower limit in x, sir?
Yeah, whenever it is greatest integer function. Greatest integer.
Okay, sir.
Without the greatest integer, we cannot. It is a greatest integer, so that substitute. That I am giving idea in every question which is related to greatest integer. It is for algebraic x square, x cube. In that case, you should take lower limit. But whenever square root is there, when you write 1 square, whenever you can write 1 square, then only. Here 2 square I have written, then only I am taking this lower limit is 2 alone, not 2 square. Actually 2 square is 4. Don't take 4. You have to take only 2. Base alone you can take. Don't consider the power. Right?
Okay.
Got it? Okay. Next one. See here, this question very easy. X whole cube. X whole cube nothing but, is it x cube of greatest integer of, both will be different to each other. Greatest integer x cube is different from greatest integer x whole cube. This is different, this is different. How can you split the interval here, Amma? N1, you only tell me. 0 to 11 is there. 0 to 11 can be written as 0 to first, 1 cube or only 1?
1.
1. Don't take 1 cube because not inside cube. Cube is outside the greatest integer. So 1 to 2, 2 to 3, 3 to 4 till 10 to 11. Okay, fine. In all the cases, x cube. Okay, 0 to 1, 0 to 1. What is the x cube greatest integer of x? Anyone? 0 to 1. Yeah, 0 cube. 0 cube is the cube. Plus 1 to 2.
Sir, 1.
1 cube. 1 cube we have to say. 2 to 3, 2 cube. 3 to 4, 3 cube. Okay, 3 cube. So on till last one is 10 cube. Nothing but what you understood here. 0 cube is 0. Plus 1 cube from x from where to where 1 to 1 to 2 means 2 minus 1, 2 to 3 means 3 minus 2, 4 everything is 1. So finally here we are going to find 0 cube plus 1 cube plus 2 cube plus until plus 10 cube. This value alone we have to evaluate. When you take 1 cube, 2 cube, 3 cube outside, remaining 1 is x is from 1 to 2 is 1, 2 to 3 is 1, 3 to 4 is 1, everything is 1. So just cube root formula, that is n into n plus 1 by 2 whole square. This value only you can find. So 10 square 11 square by 4. This we can evaluate. You are going to get the value. Got it, students? Got it?
Yes, sir.
Yeah, this is once again very easy question, Amma. I'll explain you, then we'll finish it, take step functions. Okay, fine. 0 to pi by 4. What is pi by 4? I want to know pi by 4. Pi is 3.14 by 4. What about this value, Amma?
Lesser than 1.
Lesser than 1. 0 point something will. What is the greatest integer of this?
0.
Yeah, 0. Nothing but 0 to pi by 4. What is the greatest integer value? 0. Greatest integer value 0. Nothing but what is the integral? 0 to pi by 4. Remaining value you can write, get to tan power nx plus tan power n minus 2x. That's all. Greatest integer directly 0 because it is not more than 1, lesser than 1. So greatest integer is 0. So but this question, what will you do here? 0 to pi by 4, the tan power n plus tan power n minus 2 into dx. Shall I write this tan power n as n minus 2 plus 2? Shall I take here tan power n minus 2 is common? So when I take common here, tan power n minus 2 x is common. Remaining is here tan square x plus 1 will get dx. What is 1 plus tan square? Tan power n minus 2x into secant square x dx. Now students, here 0 to pi by 4, and also you have to remember one of the important formula, like f power n of x into f dash of x dx is equal to f power n plus 1 by n plus 1. Let's see. What is the formula I have given? Function power n, its derivative is together, then whatever the power is there, just adding 1 by n plus 1. Now tan x is there. Look at here. Tan x is there. Tan x derivative is there. So what is the function then here? The function is clearly, this is f of x, this is f dash of x. Then apply the formula. In place of n, n minus 2 is there. So tan to the power of n minus 2 plus 1 by n minus 2 plus 1. From where to where limits, sir? 0 to pi by 4. It's simple. Substitute in place of x here tan power n minus 1 into pi by 4 minus tan power so by n minus 1, okay. N minus 2 plus 1 is n minus 1. Here n minus 1, but 0. What is tan pi by 4, Amma? Tan pi by 4.
1.
1 to the power of n minus 1. 1 by n minus 1. Minus tan 0 is 0 by n minus 1. Nothing but the answer is 1 by n minus 1. Simple. So what we have done here, greatest integer value becomes greatest integer value is clearly, here it is 0 only. Then tan power n x, tan power n minus 2 x, tan power n minus 2 is least value, take it outside. Then 1 plus tan square will get 1 plus tan square is secant square. So it is in the form of f power n f dash of x f power n plus 1 by n plus 1. So n minus 2 plus 1 by n minus 2 plus 1. Substitute upper limit minus lower limit, you will get the answer. Got it? So 1 by n minus 1 is the correct answer. Second option. Yeah, these questions and all you can try, students. Here 5. This is actually, this is nothing but what? X minus fx. Okay. 5 into here x minus fx. This you can try. These two questions you can try. Okay. In case if you are not getting, I can explain it. No problem. Because it is already 1.5 hours. If you write L also, right, this is also you can write 0 to greatest integer of x, 2 to the power of x minus fx. Take this, take into numerator. X minus fx is again 2 for fraction part of x. Okay, you can try, students. Otherwise, I'll be explaining. Tomorrow we'll start a reduction formula. Same special class only. We'll discuss objective. Okay, tomorrow. Tomorrow in special class maximum I'll finish it. Morning we will discuss NCERT class. Applications of integration I'm going to start tomorrow, right?
Sir, can I the last one, sir? Last thing. Thank you, sir.